Module 2, Lesson 14, the division algorithm, converting decimal division into whole number division using fraction. So we're going to move from dividing whole numbers, which is what we did in Lesson 13. We are going to divide with decimals, but we are going to use our knowledge of fractions to help us turn these decimals into whole numbers. So first I can solve for quotients of multi-digit decimals, so I can divide with decimals. And the strategy we're going to use here, I can multiply dividends and divisors by powers of 10 to help me find quotients of multi-digit decimals. So we're going to use what we did with fractions to help us use powers of 10 to work with these decimals. So we'll go through a little bit of connecting here, connect what we do with fractions to what we can do with decimals. So kind of a blast from the past here early in the module. Divide 1/2 by 1/10, and if we go with a partitive interpretation, 1/2 is 1/10 of some number. And if we are going to put that onto a tape diagram, half is 1/10, so I need some tenths here. 1, 2, 3, 4, 5, 6, 7, 8, 9. And if this is 1/10, half is 1/10, which means that if I've got 10 tenths, if I've got the whole here, I have 10 parts. So I would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I would have 10 halves, which would be 5. And if we were to look at this as the invert and multiply rule, we would have 1/2 divided by 1/10, and we would say that that is equal to 1/2 multiplied by 10 over 1 using the reciprocal of the divisor. And if we multiply, we have 10 halves, which is equal to 5. So there is our fraction reminder there. You might want to copy that down so that you can look at it and compare when we do this exercise again. But this time we're going to complete the same activity with decimals. So if we took 1/2 divided by 1/10 and we turned this into a decimal operation, half is equal to 5/10. We could do the fraction 5/10, which we know is equal to the decimal. And the fraction 1/10 becomes the decimal 1/10. So if we were to model this with a tape diagram, what would it look like? Well, here is our tape diagram, and we've got our tenths, 1, 2, 3, 4, 5, 6, 7, 8, 9, answering the same question. 1/2, 5/10 is 1/10 of what number? 5/10 is 1/10 of, so 5/10 is 1/10 of a number. And we could count up and say we've got 10 tenths, and so we'd have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We would have 10 5/10, 5 times 10 of them, and we would get a quotient of 5. Now, if we take a careful look here, we'll notice that the tape diagrams are the same. So dividing with fractions and dividing with decimals, really the same stuff. Not a difference in how we're modeling this, how we're representing this. Now there's another connection that can be useful to be made. We could actually take this division problem this 5/10 divided by 1/10, and we could write it in fraction form. And at this point, we can use some of our knowledge of equivalent ratios, because this is a ratio form here, and we could scale this. For example, I could say that I would like to multiply by 10/10. Remembering that the fraction 10/10 is equal to 1, because the numerator and denominator are the same, it indicates 1 whole. 5/10 multiplied by 10 is 5, and 1/10 multiplied by 10 is 1, and I get a quotient of 5. So taking a look at what we've got here, what is a conjecture that we can make? Well, because we've done all this work with ratios, and we know about scaling, I should be able to make the statement that if I have a division problem with decimals, and I write it in this ratio form here, if I multiply the numerator and the denominator by the same thing, I'll get the same quotient. They will be equivalent. When I have 7 divided by 2, that is equivalent, well, to 7/10 divided by 2/10. They are equivalent ratios to each other. If I were to put it into a table format, I have 7/10 and 2/10, and if I multiply them both by 10, like we do when we do equivalent ratio tables, I would have 7 and 2, and these ratios, this ratio here is equivalent to this ratio here. The ratio value would be the same. If I were to actually divide out and find the value, punch it into a calculator, I would find out that both of these have a value of 3 and 5/10. I could multiply them both times 100. And I would have 70 and 20. And all of these ratios, all three of these ratios are equivalent to each other because I have scaled following the rules that we have established as we work with equivalent ratios. So the big takeaway from looking at this example is I can express these decimal division problems as fractions. I can scale them up, multiplying by fractions that have numerators and denominators that are the same, so that I have whole number division. And whole number division is what we worked on in lesson 13. So instead of stressing out about the decimals, what do I do with the decimals? I am going to use my knowledge of equivalent ratios to make whole number division problems. All right. All right, so looking at exercise 1. In exercise 1, we'll have 18 and 6/10 divided by 2 and 3/10. And we have a set of instructions that we need to follow. I need to convert the decimal division expression to a fractional division expression. So 18 and 6/10 divided by 2 and 3/10. And I need to then create whole number divisors. I need this number here to become a whole number divisor. So I'm going to multiply by 10/10, which will give me 186 divided by 23. And it says right here, I do not need to find the quotient. I don't have to do the division. But I do need to explain the movement of the decimal point. So the decimal, if I'm doing a little comparison here, in the divisor here, it was 2 3/10. And over here it has become 23. Here in the dividend, it was 18 6/10, and over here it has become 186. Well, the explanation for that is that I have multiplied by 10. I took 2 3/10 and I have increased its value multiplying by 10. And we have a base 10 system. For example, if I have 2 in the ones place and I multiply it by 10, then I have 20. I have increased its value by a factor of 10, which means that the 2 in the ones place moves to the tens place. One of the great things about the base 10 system. If I want to increase a value multiplying by 10, it just moves one place over. So my decimal, my 3/10 here was multiplied times 10, so it has gone from the tenths place to the ones place. The 2 in the ones place has now moved into the tens place. It might be useful to look at a place value chart. Tenths, ones. So I had 2 and 3/10. Oh, let me add a tens here. When I increase the value of the tenths by multiplying by 10, it moves to the ones place. The ones, when multiplied by 10, moves to the tens place. So 2 and 3/10 becomes 23 because I have multiplied it times 10. So the decimal winds up moving one place to the right. Another way to think of it isn't that the decimal moved. The decimal has stayed in the same spot, but each of the digits has moved one place value to the left. And I really like thinking about that better. The decimal doesn't move. The decimal is fixed. What moves are the digits. The 3/10 becomes 3 ones. The 2 ones becomes 2 tens. All right, and here is the explanation out of the teacher's materials. I multiplied both the dividend and divisor by 10 or by 1 power of 10. So each decimal point moved one place to the right because they grew larger by 10. But once again, I really like the idea of thinking of this. It's not the decimal that moved, it's the digits. The 6/10 was multiplied by 10 and became 6 ones. The 8 ones was multiplied by 10 and became 8 tens. The 110 was multiplied by 10 and became 100. All right, exercise 2. Following the same process again, convert the division expressions to fractional division expressions. So I've got 14 and 4/100 divided by 4 and 68/100. And I need to create a whole number divisor. So I need this 8 right here, and we'll put in my place value chart. Hundredths, tenths, ones, tens, hundreds. So right now I have 4 and 68/100, and if I'm going to have a whole number divisor, the 8 in the hundredths place needs to move to the ones place, and the 6 in the tenths will go to the tens place, and the 4 in the ones place will go to the hundreds place. So I see that everything needs to shift 2 place value positions. Now, to shift 2 place value positions, the 8 in the hundredths place needs to go to the tenths, and then it needs to go to the ones. So it's going to make 2 moves. And in our base 10 system, every time we move a place value position, we've been multiplied by 10. So to get from the hundredths to the tenths, I will multiply by 10. And to get from the tenths to the ones, I will multiply times 10. So the 8/100ths is multiplied by 10 and then multiplied by 10 again, or the 8/100ths is multiplied times 100. So to get a whole number divisor here, I'm going to have to multiply this 4 and 68/100ths by 100. And if I multiply the divisor by 100, I have to do that with the dividend, because that's how we do equivalent ratios. So I've already figured out that the 8 will be in the ones place, and the 6 will be in the tens, and the 4 will be in the hundreds. The 4 right here is going to move from the hundreds, and it's going to move 2 spots. It's going to move tenths, ones. So the 4 will be in the ones place. The 0 is going to move ones and then to the hundreds. Nope, tens. Boy, almost got that wrong. The 4 is going to move from tens to hundreds. And the 1 is going to move from the 4 moves from ones to hundreds. I think I said tens there. The 1 will move from the tens to the thousands. So they're all going to shift 2 place value positions. So I now have this division problem, 1,404 divided by 468. Now, the explanation for the movement of the decimal point, I have made a big long speech about this already. I really kind of hate that they say move the decimal point. The decimal doesn't move. The numbers are moving. They're shifting place value positions. So it looks like the decimal point's moving. So for the 8 to become a whole number, I had to multiply by 100. When I multiply by 100, the 8 moves 2 place value positions, which makes it look like the decimal has moved 2 place value positions. All right, exercise 3. Same process here. All right, so I've got 162 thousandths. And I've got 36 thousandths. By the way, I've noticed on the last couple of problems that the divisor in the first problem, in exercise 1, was tenths, and I multiplied by 10. In the last problem, the divisor was hundredths, and I multiplied by 100. And so I'm wondering if this time I read thousandths, am I going to have to multiply by 1,000? Wondering, something to check here. So I need a whole number divisor. I need this to be a whole number. So I've got my thousandths, and I know you won't be able to read the writing there. I'm writing small. Hundredths, tenths, ones, tens, hundreds, thousands. So I have this 36 thousandths. So in the thousandths place, I have the 6, and I've got a 3 in the hundredths, I've got nothing in the tenths, and I've got nothing in the ones. And if I want to make this a whole number, then all of these things have to move place value positions. The 6 needs to come all the way over here to the ones, which means it's going to have to be multiplied by 10, multiplied by 10, and then multiplied by 10. It has to be multiplied by 10 3 times. Times 10, times 10, times 10. And 10 times 10 times 10 is 1,000. So I'm going to multiply by 1,000. Which, by the way, I was wondering if I was going to wind up multiplying by 1,000. So the 6 has moved to the ones place. The 3 needs to move to the tens place. And the 0 is going to move to the hundreds place. And this 0 in the ones place is going to move to the thousands place. So I'm left with 36. And as I look at the 162 thousandths here, it will be a similar type process. The 2 is going to move to the ones place. The 6 will move to the tens place. And the 1 will move to the hundreds place. And I've already done the explanation. I've multiplied each of these by 1,000. so that everything has been increased in value 1,000 times. All right, taking a look at example 2, we are going to evaluate the expression, which means we're actually going to do the division. And we are going to convert the decimal division expression to a fraction division expression in order to create a whole number divisor. So we're not just going to make the fraction division expression, we're actually going to divide it this time. So I've got 25 and 2/10 divided by 72 hundredths. I heard hundredths when I read this 72 out loud, so I know that I'm going to multiply by 100 hundredths. And on the last 3 problems, we have established then that the 2 is going to move to the 1's place, and the 7 is going to move to the 10's place. Because when we multiply by 100, everything shifts 2 places. And the same thing will happen to the 25 and 2/10. This 2/10 is going to move 2 places. The 5/10 is going to move 2 places. And the 5/1s and then the 2/10 are going to move 2 places. So I get 2,520. And now I am supposed to use the division algorithm to find the quotient. So 2,520 divided by 72. And we have practiced doing a little bit of estimation here. I'm then going to round this 72. And I'm going to say that's kind of close to 80. And I'm going to do that because this 2,520, I'm going to round that to 2,400. And I am going to estimate then an answer of about 30. Estimated answer. All right, so now I need to do some division, and I've got 72 here. As we practiced yesterday, I should probably go through and make my chart. So that's times 1, times 2, 3, 4, 5, 6, 7, 8, 9. All right, for 3, 70 times 3 is 210. 2 times 3 is 6, so 216. And times 4, I just double the 144, 288. And then I can add 72 on. 2 plus 8 is 10, and I regroup that. 1 plus 8 is 9, plus 7 is 16. Regroup. 1 plus 2 is 3, so 360. For 6, I will double the 3, so 432. For 7, I can add 72 more on. 7 plus 3 is 10. Regroup it in with the 4. 1 plus 4 is 5. For 8, double the 4. I've got 400. 88 doubled is, 80 doubled is 160, and 8 doubled is 16. Do a little combining here. 576. And for 9, I can add 72 more. 2 plus 6 is 8. 7 plus 7 is 14. Regroup the 1. 1 plus 5 is 6. All right, so now I am all set up to do my division here. 2,520 divided by 72. The 2,000s get kind of messy if I do that. 25 hundreds gets kind of messy if I do that. 252 tens. That works pretty well. It looks to me like I will use the 3 here. And 3 times 72 gives me 216 tens. And I'll subtract. 12 minus 6 is 6. 4 minus 1 is 3. And then I can turn those into ones, 361s. And it looks like I'll use the 5 here. 5 times 72 gives me 360. And I have a calculated quotient of 35. A quick double check with my estimate of 30. And I would say that I am pretty reasonable. Pretty reasonable. All right, taking a look then at exercise 4. Convert the decimal division expressions to fractional division expressions in order to create whole number divisors. Compute the quotient using the division algorithm. Check your work with the calculator. Cool. All right, so I've got 2,000. Let's switch back to blue here. 2,000 divided by 3 and 2/10. I heard tenths, so I'm going to multiply times 10. And when I multiply by 10, the 2/10 becomes ones. And the 3 ones becomes 3 tens. And up here, everything is going to move one place, so the 2,000s becomes 20,000s. So I have 20,000 divided by 32. Now, if I were to do a quick estimate here, I would take the 20,000 and I'm going to round that up to be 20,000 because that's nice and easy to divide by 30. And the 30 becomes 3 tens, and this becomes 2,100 tens. So the tens will cancel, and I've got 2,100 divided by 3, which gives me about 700. So I'm estimating an answer of about 700. All right, on the side here, I probably need my chart. 32, 64, 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, if I'm going to multiply times 3, 30 times 3 is 90. 2 times 3 is 6, so 96. For 4, I double the 2, 128. For 5, I will add 32 more. 8 plus 2 is 10. Regroup. 1 plus 2 is 3. Plus 3 is 6. And then for 6, I'll double the 3. 96 and 96. 90 and 90 is 180. 6 plus 6 is 12. 192. And then I can add 32 more. 4, 12, 224. I could add 32 more. 6, 5, and 2. And I could add 32 more. 8, 8, and 2. All right, so now I am all set up for this. So 2 10,000s, 20,000s, 20 divided by 32, not very pretty. 200, yeah, I like that. The 200 divided by 32, and I'll use a 6 here, and it's my 200 hundreds, so I'm in the hundreds place, and 32 times 6 gets me 192, and now I have to successfully subtract, try not to mess this up here, and I've got 8 hundreds left over, so I'll turn those into tens, so I've got 80 tens, and 2. So 2 times 32 gives me 64 tens, and I've got 16 tens left over, and I'll turn those into ones. So I've got 161s left, and I see a 5 here, and that divides my 161s, and so I have 625. My estimated quotient was 700. I'm in the ballpark. All right, taking a look at exercise 5. So I've got 3,581 and 9/10 divided by 4 and 9/10. I heard tenths in the divisor, so I am going to multiply by 10. And when I multiply by 10, everything shifts one place value to the left, so 4 and 9/10 becomes 49. And this 3,581 and 9/10 will become 35,819. So I need to make some 49s. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now 49 is really close to 50. Oh, you know, I should make an estimate here. 35,000 divided by 50. Well, divide them both by 10, and I've got 3,500 divided by 5, which sounds to me like 700. So I'm going to estimate a quotient of 700. Okay, now dividing by 49 is really close to 50. So 1 times 49 is 49. So if I do 2 times 50 and subtract 2, I get 98. 3 times 50 is 150, and I subtract 3, 147. 4 times 50 is 250, and I subtract 250. 200, and I subtract 4, 196. Now another way to look at this is I am adding 50 and subtracting 1. 147 plus 50 is 197, minus 1 is 196. So there are lots of ways to think of this. 50 times 5 is 250. 250 minus 5 is 245. And I can add 50, 295, and subtract 1, 294. 7 times 50 is 350, minus 7, 343. And then I can add 50, 393 minus 1, 392. 9 times 50 is 450, minus 9, 441. All right, so I've got my chart all set up here. And now I can work my division problem. 35,819 divided by 49. I'm going to work with the 358 because the 3 10,000s isn't going to be very nice to divide, and the 35,000s isn't going to be very nice. But the 358 hundreds, that's probably something I can work with. And I can see right here that 7 works nicely. So 358 hundreds divided by 49, 343. And that'll leave me with 151 tens. And 151 tens, if I use a 3 here, 147. And that'll leave me with 49 ones, and that's a 1. So I have a calculated answer of 731. I think I did okay. Estimated answer there was 700. I came up with 731. All right, taking a look then at exercise 6. 893 and 76 hundredths divided by 21 hundredths. And I heard hundredths, so I'm going to multiply by 100 hundredths so that I can have 8, 9, 3, 7, 6. Boy, that's a big number. Divided by 21. And over here, I'm going to, well, make my estimate first. I'm going to say that this is about 90,000 divided by 20, which will give me about 4,500. Divide them both by 10, and I've got 9,000 divided by 2. 4,500 is my estimate. Make my chart. 1, 2, 3, 4, 5, 6, 7, 8, 9. And I've got 21. That's one more than 20. So I'll multiply by 20, and I'll add. So 20 times 2 is 40, plus 2 more, 42. Why 2 more? Because I am multiplying by 2. Here I'll add 3, 4, 5, 6, 7, 8, and 9. So 20 times 3 is 60, plus 3 is 63. 4 times 20 is 80, plus 4 is 84. 5 times 20 is 100, plus 5 is 105. 6 times 20 is 120, plus 6 is 126. 7 times 20 is 140, plus 7 is 147. 8 times 20 is 160, plus 8, 168. And 9 times 20 is 180, plus 9 is 189. And of course, I would have some students in my class who notice the 1, 2, 3, 4, 5, 6, 7, 8, 9 in the ones place. And of course, there's a pretty simple explanation. We're just adding one more every time. All right, so now I've got a division problem to solve, and I'm going to do a little bit of erasing here so I've got a little more room. All right, so the 8 10,000ths, Now 89 thousandths, that looks pretty nice because the 89 is greater than the 21. That's kind of what I'm looking for here. So if I take 89 thousandths and I'm going to split it into the 21 here, looks like a 4 is what I like. And 4 times 21 gives me 84, and I can subtract. I've got 5 thousandths left over. I'll turn those into hundreds, and now I've got 53 hundredths. And it looks like a 2 will work nicely. So I'll take out 42 of the hundreds, and that'll leave me with 100, and I will turn that into tens and have 17 tens. 17 tens isn't going to work so well. So I'm going to go and turn those right into ones, and I've got 176 here, and I have this feeling that I have done something wrong. I hate that feeling of having done something wrong. Oh, and here it is. Get in a hurry, make silly mistakes. So I'm going to back up here. I did the 84, so I multiplied times 4. And I subtracted, and I got the 53. And I did 2. And the 2 times 21 got me 42. And when I subtracted, I did the 3 minus 2, but I didn't do the 5 minus 4. So I had 11 hundreds left over, and then I can turn those into tens, and I've got 117 tens. That looks much better. And if I divide that by 21, I have 105, and that will leave me with 126 ones, and multiply times 6 here. So I have a calculated quotient of 4,256. And my estimate was 4,500. I'm in the ballpark. All right, exercise 7. Now all of a sudden, our decimals got really big. I've got 6 and 194 thousandths divided by 326 thousandths, and I'm going to multiply both of these by 1,000. So I've got 6,194 divided by 326. That is kind of a that's a big number there. But it's no big deal. I got this. I'm just going to use the strategies that we have practiced. Quick little estimation. I've got 6,000 divided by 300. I'm going to estimate the answer as 20. The quotient, I think, is going to be 20. So I've got 326, 652, and making your multiplication chart on the side for this one, you have to start at this point when you're doing 3 digits, asking, is it really worth it? It takes a bit of time. So you'll have to decide if you want to keep doing that, or if you have developed some other strategies to help you out. 1 plus 7 is 8, plus 2 is 10. Regroup, 10 and 3 is 13. 326, 10, regroup, a 3, a 6, a 1. So I've got up to 5 there. I'll stop there, and if I need to go further, I will. So 6,194 divided by 326. I've got the 619 right here that I'll work with, and that would be 1 whole. 326, and do a little subtraction. I've got a 3. 11 minus 2 is 9. 5 minus 3 is 2. And then I've got a 4 here. Looks like I'm going to have to go a little bit further. Now, I'm going to use a little bit of mental strategy here to help me out. This is about 300. 1,600 and 300, that gets me to 1,900. That's not far enough. 6 isn't enough. If I add 600, 16, and 6, that gets me to 22. That's still not big enough. 22 and another 300 gets me to 2,500. Still not big enough. Add another 300. So I'm really thinking I probably need to have the 9 down here. Now to get the 9, I can add the 4 and the 5 together. 4, 3, 9, 2. And you know what? It actually divided out with no remainder. So I hope you can see how I used a little bit of estimation to help me decide where on my chart I needed to go after that first 5. My estimate was 20. My calculated quotient was 19. That's pretty good. All right. Now going back and applying all of this to kind of a real-life situation here, Blast from the Past Module 1, looking at unit rate. We're trying to figure out what is the plane's unit rate. We'd like to know how many miles per 1 hour it is traveling. So if we represent this as a fraction, I've got 3,625 and 26 hundredths to 6 and 9 tenths. And of course we've got miles and hours. Now it would be helpful if I could get both of these to be tenths. Kind of set it up as my fraction division using unit form here. So if I were to represent this as tenths, I've got 3,625, it's actually 36,252 and 6 tenths. And I've got 6 and 9 tenths. So now I've got them in the same unit form. And if I want to estimate, then I've got 35,000 divided by 70. 3,500 divided by 7. I'm going to estimate that I would have 5,000 tenths. Which would be the same as 500 wholes. So I'm going to estimate a quotient here of 500 miles an hour. Now I know I took a little detour there playing with the tenths for the estimation, but kind of a cool thing. I estimated it in tenths and then I turned it into wholes. If we just estimate with the wholes, I've got about 35,000. And this is about 3,500. 3,500, and it's divided by 7, which gives me the estimate of 500 that I found playing with the tenths in this step before. Now, if we're going to get the divisor to be a whole number, I've got to multiply, and this is what we practiced all day today. 3,625 and 26 hundredths divided by 6 and 9 tenths. And I would multiply both of them by 10, and I would have 36,252 and 6 tenths divided by 69. And of course, at this point, I can actually do a bit of division. This middle section may seem kind of silly, but we're just extending our thinking as far as place value and how things work. Nothing earth-shattering there. All right, so I've got 36,252 and 9 tenths, and I'm going to divide that by 69. And this is where the place value becomes very important. Notice I've copied the decimal up right away because I always forget that. Making my multiplication chart off on the side here, running a bit out of space, I think. I think if I advance to the next slide, aha, I left myself some room to work this problem. All right, so I've got my multiplication chart. 1, 2, 3, 4, 5, 6, 7, 8, 9, and I've got 69 here, so I'm working with multiples of 70 and then subtracting out. So 70 times 2 is 140, minus 2 is 138, 70 times 3 is 210, minus 3 is 207, 70 times 4 is 280, minus 4, 276, 70 times 5 is 350, minus 5, 345. 70 times 6 is 420, minus 6, 414. 70 times 7 is 490, minus 7, 483. 70 times 8 is 560, minus 8, 552. And 70 times 9 is 630, minus 9, 621. So I've got my chart. I'm all ready to go here. I'm going to start with the 362. Looks like a 5 here. And I'm going to be very careful about my place value. I'm dividing the 362, so the 5 goes right here in the hundreds place. 362 hundreds. The 5 is in the hundreds place. 345. Do a little subtraction here. 12 minus 5 is 7. I've got 17 hundreds left over, and I'm going to bring down the tens, and now I've got 175 tens, which will divide twice. 138. 15 minus 8 is 7. 6 minus 3. Now I'm in the ones. I've got 372 ones, and I'm back to the 5 again, which is 345. And now I've got 279 tenths. Although I'm pretty sure I copied this wrong, and this should be a 6 right here. There we go. So I've got 276 tenths, and that is a 4. So I am pretty sure here that I have calculated 525 and 4/10 miles per hour. All right, so a strategy to convert a decimal divisor into a whole number. Well, I can multiply the numerator and the denominator by the same number. And so far we've used powers of 10. We've multiplied by 10 over 10, 100 over 100, 1,000 over 1,000. Now this poses the question, does it always have to be a power of 10? Do I always have to use a power of 10? So you probably want to pause and think about that for a minute. Give you some hints here. Think about building equivalent ratios. Do you always have to multiply by a power of 10? And so looking at an example here, what about 105 divided by 3 5/10? If we're following the powers of 10 rule, we've got 105 divided by 3 5/10, and we would multiply them both by 10. And we get 1,050 divided by 35. And we would divide that out. And we'll quickly, off on the side here, 1,050 divided by 35, 35 times 3. 30 times 3 is 90, 3 times 5 is 15, that's 105. And I get a quotient of 30. What if I multiplied by something that's not a power of 10? And by multiplied, I mean my scaling here. I notice that this is halves. If I double halves, I get wholes. So what if I multiplied by this? 2 over 2. And so the 3.5 is doubled to be 7, and the 105 is doubled to be 210. 210 divided by 7 is 30, which of course is the quotient that we just got. So do you have to use powers of 10? No. As long as you're multiplying or scaling the numerator and denominator by the same factor, you will get the same quotient. We use powers of 10 because it is easy to move through the place value system with powers of 10. But that doesn't mean that we can't use a little bit of math common sense and say, well, if I double halves, I have wholes, so why not just double instead of multiplying by 10? All right, so that concludes Module 2, Lesson 14. Looking at changing decimals into whole numbers using our knowledge of fractions so that we can divide and find quotients. Lots of good stuff in this lesson, lots of good thinking. If you've got questions, make sure you talk to your teacher, make sure you complete your problem set.